half of Pier 9 is a playground for basically people to come have a residence or Autodesk employees to use the output stuff utilizing their software. And I saw this thing, and it was on the top left corner of that shelf. And we had done this whole tour. They had CNC machines and laser scanners and etchers, all kinds of stuff. It was amazing. And then that little guy, he's like, "Is there any questions?" And I go, "Yeah, I'm the drone guy. What's up with that?" And so here's the end result. This is from a piece of software called Dreamcatcher, and hopefully you like this.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now, with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
So generative design, very, very interesting. I was tripping out when I saw that thing. And just the structure, I was like, how the heck do you design that? Another area that is going to be interesting is the use of LiDAR. So originally LiDARs or traditionally they've been laser scanners from the sky. So what you have is a laser and a mirror spinning around, and it's basically doing a beam. A flash-based LiDAR is taking a grid. In this case, this flash LiDAR unit, it's only 128 by 32 pixels, and it's 10 hertz or 10 frames a second. But it's getting, as if it's like a global shutter, so it's getting a whole photo, so to speak, but it's LiDAR data, so it's depth data doing a point cloud 10 times a second in this case, and that's already up to 15, 20, I think it's closer to 30 now. So this company Brash Tech at Exponential had a Matrix 600, and then they had this unit is created by that previous company slide I just showed you. And then they're including, in this case, it's just a point gray. There's various cameras they have. It's like a machine vision camera. So you're getting probably about 2 to 5 megapixel photo of it, as well as getting a blast of LiDAR data. And in real time, they are piecing those two together. They're texture mapping the LiDAR point data. So that was huge just to think about. Here's what the setup looks like a little more close up. And then here's one of the concepts they were showing that I was just blown away by the functionality. So they flew around a cell tower with the Matrix 600 and shot all the photos and blasted all the LiDAR shots at the same time. Those two are pieced together. After the fact, they then had a 3D model of it. Well, it's so many images and it's so much data that they kind of did a scaled down lower res version of this 3D tower. I'm at the booth at the trade show, and they've got this HoloLens from Microsoft. So you put these goggles on, and what I'm looking at, not even 5 feet in front of me from my perception, is this tower. Mm-hmm. And I can reach my hands out, and if I look around, I notice there's some corrosion in a section of it. And based on my perspective of where I'm looking at the tower, I can click on that, and it will draw from the database and pull up the photo from the drone that was at that particular perspective and have an array of photos that were shot around that perspective. So instantly you're doing inspection from your office from stuff that was done out in the field. And to combine those two together in real time is quite a phenomenon. I was blown away by this one thing. And there wasn't that many people going by the booth, so I wasn't sure, is it not that many getting it or what? Because I've been searching for LiDAR for a long time. What Continental's doing with it is they're actually putting it right here on the corner of the automobiles. And why it's a big deal to have automobiles and automation from us as UAV, UAS, drone people is because this is going to drive the cost of LiDAR down to probably $250 to $1,000. It's probably going to be in consumer-based drones not very far from now. So as the car is going down, it's getting depth about up to 30 meters away from all four sides based on where the cameras are all at, which is just phenomenal what that's enabling things to do. So this was extremely exciting when I saw it. Another interesting use or another technology on the horizon is tying things together. So a leaf picking robot, what are you doing, Mark? We're flying in the air, what do you got here? So they send out a UAV doing multispectral imaging, and they notice on this peanut field that there's an issue with a certain area, certain section of the field. So then they send out a tractor that drops off this robot. The robot rolls over, has GPS location, has machine vision, so it's got a camera right there to be able to see what actually is going on, can sense the leaf that's damaged, pick it up, pull it from the plant, put it in a jar so it's geotagged that that's the particular plant it came from, and then grab other plants around, come back, and all that can be analyzed, and then the proper remedy can be figured out, which would then yield greater crops. So tying automation processes across various technologies. So the drones, the robotics, all kinds of things like that tying together. That was super exciting to see that kind of stuff. Georgia Tech, Barry McMurray doing some pretty cool stuff up there. I'm hoping next year, hopefully we do this again. I'm hoping we can get him to come out. Another thing that excites me is just the ability to fly longer. But the VTOL stuff that I've seen, this is NASA Ames on the lower right. This one was a funky unit. Takes off vertical, but then as it starts to, the propellers all rotate, the wings will naturally start to turn into wings. A lot of good options, a lot of good designs, nothing really solidified as you can buy that now. So I think VTOL is going to be nice just for getting longer flight times. A lot of these strange upright position launch and landing, saw a lot like that. They were actually fairly large. Power options, I'm not suggesting these are the greatest, not whatsoever. This one on the left is another DJI Matrix 600, but they put a gas engine on it. The gas engine provides propulsion, so the rotors aren't doing so much of the work, but the strangest thing about it was the gas engine was mainly there to charge the batteries. They were getting about an hour of flight time. It's just really loud. So that was interesting. Cabling, so tethered. There's a lot of tethering options starting to come out, which it looked like that was going to be a good thing because you could avoid a lot of the FAA rules because you're flying a kite, so to speak. And then the FAA decided, no, that's a drone in the air. Okay, we got to change something. So they're going to have to figure out exactly what's going to go on with that. So I'm not saying that these are the best by far. I mean, battery life increases are going to help a lot. We'll just see what kind of happens. Other than that, I don't know. Personal vehicles? So does this some of you guys, does that bring anything to mind? Yeah, lawn chair Larry. So the problem is that I'm worried about the following generations. If they don't remember what we did, there could be a problem that we might repeat it. But a hilarious quote up here. We know he broke some part of the FAA, and as soon as we decide which part it is, some type of charge will be filed. So I was going to lead into Ruprecht's talk with my little spiel there, but just real quick, just a few things about some of the interesting technologies that are coming up that are downright. Some of them are incredibly strange and exciting, but it's going to be interesting to see how it adjusts things. I really like the generative design thing from Autodesk and what that's able to do. I could see automotive bodies. No, the frames being incredibly different than they are today, but the bodies would still look the same. So just that optimizing the materials that are used.
Okay, great, thank you.
Thank you.